the PPT.
Yes, sir.
Yes, sir.
Where did we stop last class? Somewhere here.
So we wrote down the design procedure.
Noted down the design procedure. Huh? Okay. Okay. Anyway, we'll recap once again. So just what we have is the riveted joints. So number the rivets 1, 2, 3, 4. Then from CG, join to the center of each of the rivets. Call them as L1, L2, L3, L4 accordingly. And draw lines perpendicular to lines L1, L2, L3, so on. Okay, which will indicate the secondary shear force F1, F2, F3, and F4. Direct load will act on each rivet in the direction of applied load. The angle between direct shear force and secondary shear force is angle theta 1, theta 2, corresponding to the rivet numbers 1, 2, 3, 4. This is what, and this will induce shear stress. And what we have taken is we have to find out the center of gravity of the joint by finding out x bar and y bar. And we need to find distances L1, L2, L3, L4. Then identify the rivet which is farthest from CG and theta less than 90, which is considered as heavily loaded rivet. Then for that heavily loaded rivet, find out cos theta, then direct load, load by number of rivets, normal load on heavily loaded rivet we are going to find out. So for the if L1 rivet number 1 is heavily loaded, then we consider L1 as the distance. And in the denominator it is sum of all the distances square. Then a resultant load we are going to find, and then shear stress is equal to load by area of the rivet. From there we can find the diameter. Okay. So our design procedure we have taken now.
Yes, sir.
Okay. So we'll start with a problem. Please note down the problem. Find the diameter of the rivet in the joint as shown in figure. Maximum shear stress in the rivet is limited to 60 megapascal. The maximum load carried by the bracket is 42 kilonewton. That is, this is 42 kilonewton over there at an eccentricity of 200 mm. So this is eccentricity 200 mm. Eccentricity is the distance from CG of the joint to the point of application of load. That is eccentricity. Find the bearing stress if thickness of plate is 10 mm. So that we'll do later. Please note down this problem and note down the sketch as well. This is 50 here, okay? Same 50 I am writing here. This is 75. Note down both the sketch and the problem, and then let me know. This is one plate and this is the second plate, which are fastened together through riveted joints. Finished, huh? Finished writing?
1 minute, sir.
Yeah.
I'm done, sir.
Done. But sketch is also over. Prayag, note it down.
Yes, sir.
Okay, we'll look at the analysis part. Yeah. Now, first job is to find center of gravity of the riveted joint. So by taking sum of the distances. So for x1, x2, x3 values, okay, how we are going to go about is take y-axis as the reference. Okay, can you see this? Okay, so this is the reference line for taking distances in horizontal direction. Are you with me now? Are you with me, Prayag Mundia?
Yes.
Yeah. So the rivet number 1 distance is going to be 0 because it's on the x-axis. Okay, I mean y-axis rather, and distance 2 is 50 plus 50 put together is 100 mm. So rivet number 2 is 100, rivet number 3 is at a distance of 100, rivet number 4 is also at a distance of 100, whereas rivet 5 and 6 have distances equal to 0, 0. Okay, so therefore add and you will get the in x direction CG distance is at a distance of 50 mm. Similarly, come to y bar. So take the rivet line 4 and 5 as the reference. So once you take that with reference to this line, travel upward, that is in y direction. So rivet number 1 has a distance of 75 plus 75. Okay, that is 150. Similarly, rivet number 2 is 150. Rivet number 3 has got distance 75 mm. Rivet number 4 is 0, 5 is 0, and rivet number 6 is 75 again. Find out y bar. Is that okay? Is that okay?
Yes, sir.
Yeah. Please, please complete this x bar and y bar. Then we'll go next. Go to next step. First problem we'll understand more clearly. Finished, huh?
Yes, sir.
Yeah. Now what we need to do is we need to draw lines connecting CG to center of the rivets, correct? To find out L1, L2, L3, L4, L5 and L6, correct? So what you do is if you want to have clarity, you can write separately the 6 rivets and then write down, or already whatever the sketch that you have taken, use that sketch only from CG of CG of the joint to the center of each rivet. Call them as L1, L2, L3, L4. Okay, this L4, L5, and L6. Just do that job first. Connect from CG to the center of each of the rivets. To the center of each of the rivet, you connect with a line, call them as L1, L2, L3, L4, L5, L6. Done?
Yes, sir.
Yeah. Now what is the next step that we need to do? Draw lines perpendicular to L1, L2, L3, L4 and call them as F1. This is F2. That is secondary shear forces is what we are drawing. This is F3, F4. This is F5. And this is F6. FD. And so on. Okay, so write down F1, F2, F3, F4, F5, F6, F. Okay, so they will give you secondary shear forces and then draw FD from each of the rivets, okay, vertically downwards. From each of the rivet, draw FDs. Finished, huh? Did you finish?
Yes, sir.
Okay. Now, my job is to find the distances L1, L2, L3 and L4, correct? So we have L1, L2, L4 and L5. This is L1, okay, L2, L4 and L5. So how we can find out is by Pythagoras theorem, right? So use that. What we have is x in x direction is 50, y direction is 75. Okay, this is 75 and this distance is going to be 50. This is 75. So if you want distance L1 over here, okay, so just take square root and use Pythagoras theorem, calculate L1, L2, L4 and L5. That should give you 90.14 mm. Just calculate and let me know if there is any variation. Okay. Done?
Yes, sir.
Next, we have L5, L3 and L6. Okay, L3 and L6. This is the distance. So it's going to be horizontal distance. That is what? What is the value of L5 and L3 and L6 now from CG? What is the value of L3 and L6? Yeah,
50 mm.
50 mm. Okay. So L3 and L6 is equal to 50 mm. So we have found out distances of center of all the rivets to CG. Now we need to identify which rivet is heavily loaded. What is the condition? Condition: the rivet should be farthest okay, rivet. So we have L1, L2, L4 and L5 being farthest. So we can straight away discard L3 and L6 because that distance is less compared to these four rivets. So farthest rivets are 4. And again, next condition is, what is the next condition? Theta should be less than 90 degrees. Okay, so come back to the sketch over here. So here we have got for rivet 1, theta being larger. For rivet 2, theta 2 is less than 90 degrees. Then theta 4 is also less than 90 degrees. So we have L2 and L4 are heavily loaded rivets because why? Because theta 2 and theta 4 are less than 90 degrees compared to theta 1 and theta 5. Are you with me? Are you with me?
Yes, sir.
Right. So L2, rivet number 2 and rivet number 4 are heavily loaded rivets. So take either one of them. So find out cos theta. So X distance is 50 mm by 90.4. Okay. From there you get value of cos theta. Then direct load is F by number of rivets. So that should give you the value. Then find out normal load. Then find out resultant load. Then equate it to the shear stress equal to a resultant load divided by area of the rivet. You will get the value of diameter. That's all you need to do. Just follow the steps accordingly and finish it. Complete the problem and let me know. Any doubt here? Anybody? Any doubt in this? Not on? Answer your roll call. Meantime, 1.
Answer.
2. Abhishek GL, are you there? 3. 4. 5. 6. 7. 8.
Present, sir.
9. 10.
Present, sir.
11. 12.
Present, sir.
13. 14.
Present, sir.
15.
Present, sir.
17. 18. 19. 20. 21.
Yes, sir.
22. 23.
Yes, sir.
24. 25. 26.
Present, sir.
27. 28. 30. 31. 32. 33.
Present, sir.
34.
Yes, sir.
35. 36. 37. 38. 39. 40.
Yes, sir.
41. 42. 43.
Yes, sir.
44. 45. 46. 47.
So
Yes, sir.
44, sir. Oh, sir. Slight lag.
44, huh? Okay.
47 present, sir.
One second. 44. Okay, so 47 is present. I have taken 48,
Yes, sir. Present.
49, 50,
Present, sir.
52, 53,
Yes, sir.
54,
Yes, sir, present.
55, 56, 57, 58, 59, 60,
Yes, sir.
61, 62,
Yes, sir.
63,
Yes, sir.
65, 66,
Present, sir.
67, Chaitanya,
Yes, sir.
Mahesh, Nishant, Ramesh, Shashank, Akshat,
Present, sir.
Sautrik Roy, Mahima Raj, Srivatsan,
Present, sir.
Madan Kumar, Suman Xavier, Manu, Shadab, Ganesh, Vijay Kumar,
Yes, sir.
Rishi, Zahir Hussain. Finished noting down? Finished? Finished, huh? If you are finished, are you there?
Yes, sir. Done.
Okay. Okay. So coming to the bearing stress, how to calculate bearing stress, I'll just explain. This is the plate that is under consideration, that is plate that is to be riveted. Okay, so I take cut section of that plate, so it will be something like this. Okay, okay, so whatever the bearing stress, that means this projected area, if it is the semicircular group, okay? So when you take the projected area, it's going to be a rectangle, correct? It's going to be a rectangle. Are you with me? Are you with me?
Yes, sir.
Yeah. So this will give you what is this distance now I have taken? This is thickness. And what will be this one? What will be this distance? It's going to be diameter, correct? So this is going to be diameter of the hole over here, and T is the thickness. So when you take the projection of that semicircular groove, what we get is a rectangle. Okay. So for that rectangle, area of cross section is given by D into T. So when you calculate bearing stress, right? So the resultant load divided by area, projected area of this semicircular groove is what we need to take for calculating bearing stress. So therefore, sigma is equal to bearing stress is equal to resultant load divided by D into T. Is that okay? This is where in this groove is where our rivet is going to be there, so that this surface is subjected to bearing stress. So how to calculate area is to take projection of that semicircular groove, which is going to be a rectangle. So for area of rectangle is what we need to consider here for area while calculating bearing stress. Are you with me? Are you with me?
Yes, sir.
Yeah. Finish that. Finish that. We'll go to the next problem. Any variation in the answers? Any variation? If you have found out any variation? No
No, sir.
AVDA. And
Diameter
one
is coming
important
as
aspect is,
22.9.
which one?
Diameter is coming as 22.9.
Yeah, 22.9. But you need to take standard diameter from the table, okay? And write it as standard diameter of rivet from table so and so is 24 mm, okay?
Yes, sir.
Yeah, we'll go to the next problem. Anybody needing time to note down? Okay. Take down this problem. Find the diameter of the rivet for the bracket as shown in figure. The maximum shearing stress on the most heavily loaded rivet is 56 megapascal. Please note down the problem and note down the sketch clearly. Once you have finished, let me know. We'll go for explanation. Tomorrow, I may be taking 2 classes, one from 9:30 to 10:30, another from 10:50 to 11:50. Okay, this for your information. Tomorrow, Friday, second hour and third hour, I may be taking. Tomorrow, I think we can complete our riveted joints. So tomorrow we'll have 2 hours. Come prepared. Finished noting down? Finished, yeah?
Yes, sir.
Right. Eccentricity is 250 mm. Load is 12,500 Newton. And these are rivets 1, 2, and 3. This distance is 50 and 50 over here. So what is the first job? First job is to find the center of gravity of the rivets. So take X bar, right? So for that, I take this as reference. I take rivet 1 y-axis as reference. Okay. So the x1 is going to be 0, x2 will be 50, and x3 will be 100. Correct? So what is the value of x bar that I am going to get? What is the value of x bar I am going to get? It is 150 divided by 3, correct? So that's going to be 50 mm. Is that okay? That is the value of x bar. That is center of gravity distance in x direction is 50 mm. Okay? And what is going to be the y bar value? So this is where I take the reference line for y bar. So what is going to be the y bar value?
0.
0. Exactly. Okay. Others, could you understand why it is 0? Because all the rivets are on the same axis, so there are no rivets above or below. So y distance y for all the rivets is 0 plus 0 plus 0 divided by 3. So therefore, we have x bar is equal to 50 mm and y bar is 0. So that is the location of CG. Then what is that we need to do? We need to find distances L1, L2, L3. So what is the value of L1 and L3? So this distance from CG, this is the CG, okay? Distance to center of rivet to the CG is L1, okay? So this is L1 and this is going to be L3. This distance is L3. Okay.
Sir, I had a doubt.
Yeah, tell me.
While calculating X bar, how is it 50 plus 100? Isn't it 50 plus 50?
No, what is the reference line, Chinmayi? Reference line is this. This is the one second, one second. This is the reference line, correct? On Rivet 1, I have reference line. With respect to reference line, I need to take distances of 2 and 3 in X direction. So Rivet 2 is at a distance of 50 mm. Rivet 3 from reference line, this is the reference line, okay? Rivet 3 from reference line is at a distance of 100 mm, correct?
Yes, sir.
So therefore it is 50 plus 100 plus 0 divided by 3.
Okay, got it.
Right? Yeah. Yeah. Where was I? I was discussing about distance L1, distance L3. L1 is at a distance of 50 mm. L3 is at a distance of 50 mm. And L2 is on the CG itself. So therefore, value of L2 is going to be what? Value of L2 is going to be 0. Okay. So L1 and L3 is equal to 50 mm. L3 is farthest and has got theta less than 90 degrees. How theta less than 90 degrees? Because the angle between F3 and FD, they both lie in same line. Is that okay? Whereas the rivet number 2 has got 180 degrees as theta. This is FD acting in this direction. F1 is acting in this direction. Whereas F3 and FD both are in same direction. That is, this is FD. So FD is acting downward. And for this line, L3 line, this is the perpendicular distance. Okay. So therefore, we have theta less than 90 degrees with reference to rivet number 3. So therefore, L3 is going to be the farthest rivet and has got theta less than 90 degrees. That is, theta is equal to 0. So therefore, cos theta you find out 50 by 50. Even if you take L1 as farthest and theta, if you draw the other way, okay. Suppose if I take the riveted joints such that, so this is FD acting and this is F1 acting. In that case, what will happen? So this is going to be F3 and for this rivet, it's going to be FD. So either way, you can take, not an issue, okay? Because they are at equidistance, right? So therefore, we have L3. In this case, I have taken L3 to F3 to be acting along with FD. So therefore, L3 is going to be the heavily loaded rivet, okay? So find out direct load, then find out normal load, then find out resultant load, then find out diameter of the rivet. Is it okay? Anybody? Any doubt in this? It's very, very easy. You just follow the procedure and solve systematically. That's it. Identifying the heavily loaded rivet is very, very easy. Take the farthest of the rivets and theta less than 90 degrees. That's it.
Sir, in the figure, can you show how this, the direction, how did we decide, sir, in that?
That's what I said. You can take, see, first is to draw L1 and L3 from CG, okay? So to this L1 and L3 lines, we need to draw perpendicular lines. That's what we have done in the previous cases, correct? So we have drawn F1, F2, F3 perpendicular to L1, L2, L3, so on, right? Similarly here also for L1 line, while drawing perpendicular, I take, instead of, they will be, this is perpendicular. So this also is perpendicular for this, correct? Huh?
Yes, sir.
But in that case, what will happen? My F1 will be in this direction because the secondary shear forces tries to rotate the joint about its CG. Okay, so therefore, if F3 is acting in this direction, then F1 must act in this direction. Is that okay?
Yes,
so in
sir.
that case, what will happen? Rivet 1 will become farthest and theta less than 90 degrees. So rivet 1 becomes heavily loaded rivet. In that case also, you will get the same answers. You can take that as heavily loaded rivet and solve the problem. Instead of instead of why I have taken F3 in this direction is that my load F is acting downward. So therefore, the effect of the F value is to rotate the joint in this direction. So therefore, I have taken F3 in this direction and F1 in this direction. Is that okay?
Yes, sir.
So this F will rotate the joint in clockwise direction like this about its CG. For the joint to rotate in this direction, my F3 should be in this direction and F1 should be in this direction. That's how we need to take the direction. Is it okay?
Yes, sir.
Yeah. Complete the problem and tell me once you have completed your write-up.
Sir,
Yeah.
Fn equal to FeL2, the
Ah.
formula, the L2
Oh,
is.
sorry, yeah.
You
It
put
should be Fe L3. It's Fe L3. Thank you. Others, please note down. Don't simply switch on and keep quiet. Finished, huh? Finished? Done? Anybody needing time to note down? Okay.
Done.
Yeah. Please note down this problem. Make it fast. Please note down this problem. A bracket is supported by means of 4 rivets of same size as shown in figure. Determine the diameter of the rivet if the maximum shear stress is 140 megapascal. Given eccentricity is 80 mm, load acting is 20 kilonewton on the joint, and these distances are 30, 30, and 30. You can name them as 1, 2, 3, and 4 rivet numbers. Please note down. Did you finish writing?
1 minute, sir.
Yes, sir.
Yeah.
Done, sir.
Yeah. So try solving this problem. So this is how you can name the rivets 1, 2, 3, and 4. First thing. Next thing is to draw L1, L2, L3, and L4 from CG, correct? So CG will be exactly at the midpoint in this case. That is at a distance of 45 mm. So how do you get it? Because x value is going to be 0 in this case, correct? Like in the previous case, we had y bar being 0, okay, because all the rivets are on x-axis. Now the same thing, but it's in opposite, that is all the rivets are on y-axis. So therefore the distances x is going to be 0 for each of the rivets. So therefore x bar is going to be 0. Y bar is going to be with reference to a line at the bottom, right? That is if I take some L4 as a reference over here, so L1, L2, L3, you calculate the distances and then try solving this problem. Okay, so tomorrow, as I said, we will meet at 9:30. Okay, 2 hours we are going to take. Is that okay?